Yes, sir.
Yeah, please go ahead, ma'am.
Thank you. I, Lakshmi Liria, working as Associate Professor in the Department of Computer Science Engineering, Vignan's Institute of Information Technology. I welcome you all on behalf of IUCEE Webinar. Today's topic is Experimental Advent of Big Data Analytics using Hadoop MapReduce. So these are the topics we are going to discuss today. In the beginning session, we'll have the introduction part, and in this we are going to learn about what is MapReduce and in which areas MapReduce will be used, what are the use cases are there, and how weather data and healthcare and its architecture, all these things we are going to see in the introduction section. In MapReduce methodology, before the availability of MapReduce, what kind of traditional approaches used to be followed, what are the MapReduce processes were there, and we are going to see about the anatomy of MapReduce program and the ways of MapReduce and the advantages of MapReduce. And the last section, we are going to see about the splittings of MapReduce and relation between input splits and HDFS blocks and the MapReduce flows. And ultimately, we are going to see about the overview of MapReduce as well as the final project of MapReduce phases. So in this session, we will try to cover maximum of experimental approach to the Hadoop. So people who have attended my previous webinar, in that previous webinar, we have discussed about the big data, the importance of big data, how the big data goes on, what kind of structured data, unstructured data, semi-structured data will comes under big data, what kind of analysis can be done, the ecosystem of big data, all these things we have covered in the previous webinar. So in this webinar, we are going to focus more on experimental approach, how the MapReduce will work. We are going to see about all these things. Let's start with the MapReduce. What is a MapReduce is? MapReduce is nothing but it is a heart of Hadoop, and it is a programming model for designing the large volumes of data in parallel by dividing the work into set of independent tasks. So what the MapReduce is doing is, the MapReduce plays the core of the Hadoop. So in the Hadoop ecosystem, when you talk about the Hadoop ecosystem, we have Hive, we have Pig, we have MapReduce, and we have HBase, and at external, I'm going to draw about the scoop. I'm going to treat this as a scoop. And we have one more component that is called as a flume. Right. So in the previous session, when we were discussing about the Hadoop ecosystem, we were discussing about these components. There is Hadoop eco components that is called as a Hive and Pig. Hive is called as the one eye, and Pig is another eye. It is not like that Hive is acting as a eye. Just for understanding's sake, we are just using the terminology of our body as a eye and all these things. And MapReduce we consider as a heart of the Hadoop ecosystem, and HBase is something like a storage. And what about the HDFS? HDFS is all about all these things. That is a major storage, we can tell you that, right? So with the help of Hive and Pig also we can perform the analysis. As I said in the previous session itself, something like when we are going on a way, suddenly a snake is coming, unless and until we see through the eyes, we cannot take a quick decision, jumping from that place or moving from that place to a safe place. So for immediate analysis purpose, then we can make use of Hive and Pig. What about the Pig? What about the MapReduce is? MapReduce is nothing but where we are writing the particular programming aspect we are going to see about it. We are going to do complete programming with concern to Java or by using the Python. Then what about the Hive and Pig is? In Hive and Pig, we are not going to concentrate much about programming part. We're going to concentrate about how the immediately analysis can be done. All these things can be done with the help of the Hive and Pig, right? So in Hive, just we are going to write 1 or 2 commands. In Pig, we are going to write about the scripts. That's all, not more than that, right? Whereas in the MapReduce aspect, what is going to happen is you are going to write long and lengthy programs. So whatever the aspects are there which cannot be performed by using a single scripting commands or single commands, then we have to go for a MapReduce. But why we are calling the MapReduce as heart of the Hadoop ecosystem? Because in MapReduce, what happens is, even though we are not writing here Hive and Pig about the MapReduce, what happens is every command is going to be converted into MapReduce. Every command is going to be converted into our MR. Every command is converted into MR. Even in Pig also, every command is converted into MR, right? Everything is converted into MR, right? So we have discussed about the scoop in the previous class, scoop and flume. So whenever we have outside the world, outside of Hadoop, if you having a structured data and if you want to perform the analysis for the structured data, we can push the scoop data into the HDFS. I'm just revising the thing. Whereas in the scoop, what happens is we are not going to discuss about the unstructured data. We are going to discuss about the structured, like whatever the data present in the enterprise level, ERP type of data, we can perform the analysis. I have given the things here. So in today's session, we are going to discuss the major part is the how the MapReduce goes on, right? So as I said, that MapReduce is the heart of the Hadoop ecosystem. Why we call as a Hadoop? Why we call as a heart of the Hadoop ecosystem? Because whatever the command we are giving, either by using a Hive or either by using a Pig, even though not writing the Java programming, every command is going to be converted into MapReduce phase only. So that is why the core part is the MapReduce, right, of the Hadoop ecosystem. So it is a simple programming model designed for processing large volumes of data, because Hadoop basically focuses about large volumes of data, terabytes, petabytes, exabytes. It deals with the large volumes of data by dividing the work into a set of independent tasks. So MapReduce is a framework which possesses the feature of data locality. What is the meaning of data locality? Data locality is nothing but it is something like an algorithm, where what we are doing is, data locality means movement of algorithm to the data instead of data to the algorithm. Yes, this is the wonderful feature of the Hadoop MapReduce. What is the important feature? Data locality. Previously, with before the availability data to this algorithm place, and what I am doing now, I am asking the algorithm to process this. Moving the data is more expensive, but what we are doing now in the Hadoop Apache, there is a reverse mechanism. What we are doing now, simply we are applying, we are throwing this algorithm into this data. There is no need to spend much amount on movement of the data. What I'm doing now, just simply I'm moving the algorithm and I'm putting on this data and I'm performing the analysis. That's what the MapReduce is doing. We are not moving the data, just that's what the excellency of Hadoop MapReduce or complete Apache Hadoop. That's the excellence of the Apache Hadoop. It's a commodity inexpensive hardware. Data movement, whenever we are moving the data, we are not moving the data. Let it the data wherever it could be. Wherever the unstructured data is there, wherever the structured data is there. So let the data could be there itself. I will not disturb the data. Just simply, I will put the algorithm into the data, and then what is going to happen? Just simply, algorithm is going to perform the analysis. That's what the job of the MapReduce. Yeah. So that's what about the data locality. And next is the next most important thing. When the processing is done on the data, algorithm is moved across the data node. So in the previous webinar, we were discussing about how the architecture of Hadoop goes on. So Hadoop architecture basically works on master-slave architecture. It works on master-slave architecture. In master, we will be having two daemons will be running, that is called as the job tracker is one and the name node is one. Whereas in the slave node, two daemons will be running, that is called as and the task tracker. So this is all we have discussed in our previous session. So just for an understanding purpose, I am giving a revision. When the processing is done on the data, algorithm is moved across the data nodes rather than data to the algorithm. So this architecture is constructed because moving computation is cheaper than moving data. Yes, this is the awesome feature which is making the Hadoop Apache to be more popular in the software market. Why? Because we have plenty of data, so much of data is there. What we are doing now, we are not moving the data. Wherever the data is, let it be there itself. Now what I'm doing now, just I'm pushing my algorithm wherever my data is. But moving the data to the algorithm is different. But what we are doing now, there, just let the data to be there itself. I'm applying the algorithm, right? So this is what the MapReduce is. So short and sweet, MapReduce is a programming model designed for processing large volumes of data in parallel by dividing the work into a set of independent tasks. Yeah, MapReduce has a simple model of data processing. It has a simple model of data processing, and the most important thing is inputs and outputs for the MapReduce functions are key value pairs. Inputs and outputs for MapReduce functions are key value pair. What is the meaning of this? The meaning is nothing but how the MapReduce functions is. The MapReduce functions something like this. Something goes wrong. Yeah, it was stuck. Yeah, how it goes on? It goes on something like this. So we are having a plenty of data. We are having, this is all data. Just imagine that we are having this data. Now, what the MapReduce will do? The MapReduce will read the input from the input file, and after reading the data from the input file, every line is going to be taken, and then every line is going to be divided in the form of key value pairs. That is the functionality of MapReduce. The MapReduce function in Hadoop MapReduce have the following general things that is called as how the functionality goes on is, we have a map which have a key 1 and v1, that is called the key value pair. Again from the key 1 and from v1, that is called the value 1, one more list is going to be formed, that is called as a key 2 and value 2. Again, reduction is going to be happen. What is a reduction? Reduction is nothing but simply map is a function. Map is a method, right? So if the map method, what it is doing is it is just simply reading one by one line and dividing in the form of a tuple, and from tuple it is dividing to the key value pair, right? What is the reducer function is doing? Reducer is a separate method. See, map and reduce are not one. Map duty is separate, reduce duty is separate. What is the duty of map? Map is just simply dividing, taking the input file and just breaking into as a chunks of data. The data has been taken and it's going to be broken into chunks, right? Small chunks. And what the reduction will do, what the reduce function will do, the reduce function will simply do the aggregation purpose. What it will do, it's going to do the aggregation. It's going to count, right? How much amount of data is there? It's going to do the aggregation. It's going to do the final counting job. It's going to do, right? So every program, it is not mandatory that every program must and should have map and reduce methodology both. Some program I will implement only map and I may not go for reduction, reduce method because I may not perform the aggregation job, right? I'm going to simply perform the mapping, then some other type of logic I may apply. So in which area MapReduce is used? Frankly speaking, MapReduce is applied in almost all the areas, right? In almost all the areas, the MapReduce is applied. For forecasting the weather, the MapReduce is used. For forecasting the healthcare systems, we are going to make use of MapReduce. The MapReduce can be implemented in the oil and gas industries also. So in every area, in each and every area, wherever the data is there, not with concern to computer science engineering mechanism, it will be, if the data is available from the mechanical side, we can perform the analysis by implementing the MapReduce. If the data is available from civil background, we can implement the Hadoop MapReduce and we can perform the analysis. Similarly, from the electronics and communication side also, if we have large amount of data, we can perform the, we can implement the Hadoop MapReduce and we can perform the analysis. Likewise, the things goes on. So this is our weather data, a sample data I am just showing here. We are going to work on this weather project also today. How the MapReduce works, how the MapReduce finds the weather condition from the year 2000 onwards. Likewise, we are going to see. So this is our data sets. What is data sets? Data sets are nothing but it consists of large amount of data, maybe a structured data or unstructured. But remember, one important thing is data sets once we keep into the HDFS. So that should be the end. That means that should be the end means what? Nothing but whatever the data we have applied into the HDFS, whatever the data we applied, for that only we can perform the analysis. Tomorrow's data we cannot perform the analysis because tomorrow has to come, again the data has to be uploaded, then we can perform the analysis, right? Of course, if you are working on imaginary data, obviously you can perform the prediction analysis also. So we can apply on healthcare also. So these are all the challenges present in the healthcare. What are the challenges is huge amount of data flows into systems daily, and there are multiple data sources that where we need to aggregate data. Crunching this data and de-identifying in a traditional way is the greatest problem without the Apache Hadoop, right? So we have got large amount of data is there. Crunching them, breaking into splits, that becomes a very difficult without the Apache Hadoop. So let us see about how we are solving the problem with the help of MapReduce is just understand this architecture in a slow manner. First of all, what we are doing is just imagine that data is outside the world. Just imagine that I would like to take the example of our Vignan's Institute of Information Technology. Just imagine that Vignan Institute of Information Technology does not have Apache Hadoop architecture or its framework. So just imagine that they have been working as a traditional way, or the traditional mechanism only they are applying, right? So what I am going to do now, they are going to make use of Scoop to import the data into the HDFS. So just imagine this is my Vignan Institute of Information Technology's data. I am using the Scoop mechanism here, and maybe the data may be CSV format. What is CSV format? CSV format is nothing but comma separated value format, right? It is not mandatory that you should work with CSV, any data, because Hadoop says I'm ready to do any kind of analysis, maybe a CSV format file or a text file or a structured file or unstructured file, Twitter files, or the Facebook for data, whatever data, the MapReduce Hadoop is saying that I am alive and I can do all things, right? So just imagine that this is the data we got, and now what I'm doing now, I'm putting it to the HDFS. What is the HDFS? Hadoop distributed file system. And then once we put into the HDFS, what's going to happen is there the MapReduce job is going to perform. So first, which phase is going to come? First, map phase is going to come. What the map is doing here? Map is breaking the data into chunks, right? And after the chunks will be given to the reduce. What the reduce will do? The reduce will do the aggregation. Please keep this point in the mind. Don't think that always reduction is only performing the aggregation. It is a simple logic I am explaining, but the MapReduce can be implemented at any kind of extended level of high level of mechanism can be implemented. Just for understanding purpose, I am explaining this. Right. So like this, the working of MapReduce goes on. We are putting the data. We are importing the data by using the scoop. We are dumping it into the HDFS. What is this? This is a CSV format file. Any file you can make use of it. And so it is putting into the HDFS, and then the map is going to read data and then breaking the data into chunks, and then the chunks is given to the reducer. Reducer has done the reduction. Again, the output is stored in the HDFS. See the cycle. Data is outside the world. We are importing from scoop. Maybe the data is CSV format coming to the HDFS. Again, the MapReducer is breaking the data into chunks. Again, this is the chunk, this is your broken data, right? So this is your chunk data, and that data you are giving to reducer, and reducer is counting or performing the aggregation, and ultimately final result is stored in the HDFS. Ultimately, final result is stored in the HDFS, right? So it is also a big storage area where we can store it, right? Let us see about the traditional way before the availability of MapReduce. Just imagine that we don't have Apache Hadoop. So in traditional mechanism, if you want to perform any kind of splitting and all, so how we used to split is, just imagine that we are having a very big data is there, right? We are making use of, we are splitting the data, and then we are making use of grep command. What the grep command? The grep command is for searching, right? So if it is matches, if from this data the given word is matched, then I'm going to make use of save into the another file. What is the command? Cat command is used to create a file and put the data into the file. So the grep command I have used to search data. So what we are performing in traditional mechanism is, we are having a big data. Every big data I have split it, and then I have used a grep command. If it is matching, then what is going to happen? I'm going to store into the file. So likewise, this is a sequence process is going to be happen, but it is a lengthy process and it is not a correct process also. As long as the data is less, this process can be implemented. Data means less means what? Hardly 4 lines, 5 lines, 6 lines, but we don't have such amount of data, and we don't consider also that size of data as a big size of data. The data which is measured in terms of terabytes, petabytes, zettabytes, they are all called as big data, right? So this is our traditional way and traditional approach. Yeah, the most important phase we came now. This is the thing we need to understand. If this phase we have understood, then practically we can implement it very easily, right? So people who are especially involved in the research areas, for them implementing their research work in Apache Hadoop using various ego components such as IUCEE and MapReduce, their research can be done very fast and quickly. Analysis report can be generated very quickly. That is the major benefit of using the Apache Hadoop, because Hadoop is basically for performing the analysis. Predictive analysis can be done very quickly, right? So this is the MapReduce paradigm we are seeing. The most important phase, this is it. Yeah, just imagine that we have the input file. We have the input file. This is my input file, and what the MapReduce is doing is, every line, this is my first line, is going to be taken, it's going to split. Who is going to split? Map is going to do that job. Again another line, again another line. If you ask me a question, if we are having 10,000 or some number of lines, that many number of splits are going to happen. And how do you know that how many splits has happened? When you run the program, it is going to show also the report it is going to generate. From your data, so many splits has done. 19,000, 1 lakh, 2 lakh, 4 lakhs, 7 lakhs. This many splits has been done. Like that it is going to show. So from this data, how many splits has done? Only 3 splits, only 3 lines of splits. So it is going to generate the report as what? 3 splits, that's it, not more than that. So one line, let me clear it. Yeah, one line it has taken, and another line it has taken, and another line it has taken. Right. Now, what is the next job? That is called what? Key value. So this is my key value now. Right. One pair has been formed now here. Now again, what we are doing now? Splitting job is over. Next is mapping job here. So what the mapping job? We are performing the list. We are performing the list. So key 1 and B1 is generated. Now K2 and B2 has to generate. Now what I am doing now? Dir is a key. What is the value? 1. Only dir is there 1 here. Bir, again key. What is the value? 1. River is 1 key. What is the value? 1. 1 is the value. So this line is over. Again coming to this part. Car, key. 1 is a value. Car, key. 1 is a value. River is a key. One more. What is the value? 1. Again dir, key. Value is what? 1. What is the 1? Nothing but the count. Car is a key. What is the count? 1. Beer, count. So this is like this. What happened now? Mapping has done. Mapping has done. So first step is what? This is the first step. This is one key. K1 and B1. This is my K2 and B2. Now next job is called as what? My shuffling process. In shuffling process, what I am doing now here? We are having K2 and list V2. What? From this blocks we have got 2 beers here. Again take the another word, car. Yes, wherever the car is here, no is there. Here car is there. Yeah. 1. One more car. 1 comma 1. Here is one more car. 1 comma 1. Again we are having a deer. Where is the deer? Yeah, 1. Here no deer is there. Here 1. 1 comma 1. River. Yes. Where is the river? From here 1. Here one more river is there. Yeah, 1 comma 1. This is called as my shuffling. The shuffling job is over. This is the overall MapReduce progress of word count program, right? So if anybody heard about the word count program, that is a beginning program for any Apache Hadooper, right? The people who are learning the Hadoop, they are called as the Hadoopers, and there are more and more openings for the Hadoopers. The Hadoopers can settle as a Hadoop developers, Hadoop testers, Hadoop administrators. So we are working as a Hadoop developers. We are working as Hadoop developers because we are basically focusing on programming part, performing the analysis part, whereas the administrator basically focuses on how the master node should manage, how the slave nodes are working, and whether the heartbeat is given to the master node or not, and any node is working or not, any node is dead, became a dead node or not. All these checking thing is going to be taken by the Hadoop administrator, and whether all the nodes are working properly or not. So we are going to appoint testers, Hadoop testers, right? So yeah, just we were deviated the topic. Yeah, again we are coming back here. Overall MapReduce word count process. So first splitting job is over, mapping job is over, shuffling is there for how many times? 2 times. And then the final list is going to be created here, right? And this final list is going to be stored in the HDFS. So this data is stored in the HDFS. The mapping is done here, reduction is done here, and then the output is stored at the HDFS, right? So likewise the things goes on. Just for understanding purpose, I'm going back. Yes. So what happened now? I have kept the file. What is a file? The car, beer, deer file. I have kept this. Imagine that this is a car, beer, deer file. Where I have kept? I have kept into the HDFS. What the map has done? Map has done the splitting process, shuffling process, and then given to the shuffled file has been given to the reducer. What the reducer has done? Reducer has done the aggregation. That is the final output, and the final output is stored in the HDFS. So like this, the working of the MapReduce is going on by taking the example of word count program. Word count is a simple program. Generally, for all the beginners, we make use of the word count. For understanding purpose, I have taken this example. Yeah. These are the anatomies of MapReduce programs. The basic anatomy of MapReduce is nothing but the key value is the anatomy. So we have a map, we have a K1 and V1. And from K1 and from V1, what is going to happen? A list is going to be performed. From there, we are going to generate K2 and V2. And from the reduce method, what is going to happen? K2 will be as usual. Listing is going to be performed. The reduction, the aggregation is going to be done. And ultimately, the list is going to be performed. That means what? Beer. For how many times? 3 times it is there. River is there for 4 times. Car is there for 7 times. Likewise. So overall, the MapReduce program consists of map method and MapReduce, or map function and reduce function. Now the question is it mandatory to have the map and reduce both things in the program? No. It is not like that. Whenever we want to perform only up to shuffling level, sometimes I want to perform up to shuffling level, then I'm going to implement the map method only. Map phase only I'm going to implement. Reduce phase I'm not going to implement. Why I'm not going to implement reduce phase? Because I'm not counting. Because in the previous example, I have implemented the reduce method because I'm performing the aggregation. And since I'm performing the aggregation, what I'm doing now, I'm implementing the reduce method. But if you are not performing any kind of aggregation, some sort of thing, then you don't need to implement the reduce method. You directly implement your logic or the whatever thing you want to implement, that you can implement directly, right? But the most important thing is, can a MapReduce, can a program can be written without map? No. That is very important, right? So mapping has to be done. The shuffling has to be done. Breaking into sentence to the key value pair. This is all very important. We don't call it a sentence. We call it a tuple. This is the one tuple. From tuple, we are breaking into key value pair. Yeah. So how the MapReduce ways goes on? The MapReduce ways goes on. This is for simple, short and sweet manner I'm telling here, right? So we are having a very big data, and then we have all the data broken into tuples. From tuple, we have gone for a map where we are performing the functionality, then reducing the work, performing the aggregation, and storing the result. Yes, this is about the how the job of healthcare system works on. See, it's a question of healthcare, or it's a question of word count program, or it's a question of patent counting, or it's a question of temperature program, whatever the data could be. Same mechanism is going to be implemented. Importing from the scoop, putting into the HDFS, implementing the map phase, implementing the reduce phase, putting the result into the HDFS. Whatever the kind of data, maybe a scoop data or a flume data, structured data or unstructured data, everything will goes on as usual. Yeah, this is the most important thing. MapReduce advantages. How we are going to face the advantages here is, the two most important advantages of MapReduce is, already I have spoken about data locality. What is the data locality? Data locality is nothing but taking the processing to the data, wherever the data is there. See, Already we have discussed about the Hadoop architecture. So Hadoop architecture goes like this. We have racks. In the racks we have got one node, another node, another node. We have got one more rack, one more node, node, right? Just imagine that there is a one more rack. We have one more node. Yes, these are all my nodes. So these nodes share nothing actually. These nodes, what are nodes? Nodes are the simple computers. They are nothing but they are commodity inexpensive hardware. They don't require high configured machines, no big processors, no high RAM, nothing, not like that. Of course, if you are working on single mode or a pseudo distributed mode, obviously you require a high amount of RAM. Minimum of 8 GB you must and should have. But for your master slave architecture, that's called your cluster type of thing, you don't require the nodes should be having a high processing speed. All those things are not required, because the main motto of Hadoop is nothing but only to work on commodity inexpensive hardware, right? So wherever the master node is there, that requires a little bit of RAM, that's not more than that, and processing speed. So we have got these nodes. These nodes does not share anything. These nodes does not share anything, right? So what they share the network, that's all. They share the bandwidth and network, that's a lot more than that. So when this rack, whatever the nodes present in this rack want to communicate with this nodes present in this rack, what is going to happen? They're going to make use of the rack switch. They're going to make use of rack switch. They're going to make use of rack switch. Right? And if our cluster becomes cloudy, that means just imagine that just for an understanding purpose, I would like to use my sketch. Yeah, if something goes wrong. Oh. Yeah, I'm sorry. It is some sort of disturbance came. I'm very sorry. Yeah. So we were discussing about suddenly the power of my lab was gone. So that is the reason it happened. I'm sorry for that. Sorry for the inconvenience. Yeah, we were working on. We are talking about the how the Hadoop works on, right? So what we are doing now, we are having taking processing to the data here. So what we are having, just imagine that we are having a rack. This is one rack, one more rack, one more rack, right? Just these are all the nodes. I'm having one node, another node, another node, another node. In another rack, I'm having one more node, one more node, one more node. Here also one rack. Just imagine that this rack. So as long as we are in the Vignan Institute of Information Technology, Visakhapatnam, so these racks can communicate with one another by using the rack switch. So these racks can communicate with using the rack switch. Just imagine that Vignan has got established, it has been gone to Australia or London, something like that. So I have got one more cluster in the London. I have got one more cluster in the Germany. I have got one more cluster in the Chicago, right? So that means now I want to make my cluster as a cloud. I want to make the cluster as a cloud, right? I will make as a cloud now. So what I'm going to do now, these clusters are going to connect with the rack switches, and these rack switch is going to make connect to the cloud, that is called to the internet. So this cluster is there in the Chicago, this cluster is there in the London, this cluster is there in the Germany. If time permits, in the next webinar we will try to see the live demo, how to connect the live servers of London, live servers of Germany, all those things. So those things we are going to see in the next sessions if time permits for us, right? So this is the cluster. It was now became as a cloudy. That means what? One cluster is India. Just imagine that these racks are present in India as a cluster, and some cluster is in the Chicago, another is in London, another is in Germany, and all these three clusters are communicating with the help of the cloud, right? So Hadoop has become now cloudy. Yeah. So the basic advantage we are seeing here is taking processing to the data. So wherever the data is there, we are not moving the data, because wherever the London data or Chicago data is there, I want to, if I got a job to do the analysis of that data, my boss said that you do the analysis of that data, they will not send me to London by paying the amount and all. What I have to know, my cluster has to connect to the London cluster, and I will perform the analysis simply, right? And what I'm going to do, I'm going to get the analysis record. Simply I'm going to get it, and I'm going to generate the report. That's the simplest mechanism, right? That's what the benefit of cloud. That's what the benefit of cloud computing. So this is all the interrelated concepts: the cloud computing, grid computing, and because the Hadoop works on parallel and distributed commodity hardwares. What is parallel and distributed commodity? See, some data is in one node, in another is in another node. Some data is another node, and they are working parallelly. All nodes will work parallelly. See, this node say, I am strong, I will work fast. Means no. They are working under equal bandwidth. So that is the reason they are not sharing anything. They have to work on equal bandwidth, right? So it is something like working in an educational institution. One faculty is there, another. All faculty has to work in a normal fashion, right? That is called parallel mechanism, right? And the advantage of MapReduce is a processing data in a parallel manner. It's in a working in a parallel manner, right? These are the advantages of MapReduce. The first and the foremost advantage is taking the processing to the data, and processing data is performed in a parallel fashion. Yeah, I am now, I want to show you some practical things now before going ahead, how the MapReduce works on programmatically. I want to show you, because as the motto of this webinar is to show the experimental advent of Hadoop MapReduce. So that is why I'm not going deeper into the MapReduce, because if you go deeper into the MapReduce, there are some number of other concepts are there, like combiners, partitioners, distributed cache, map side joins, reduce side joins. These are all the advanced features of MapReduce. But I want to run the simple programs for you, so I'm moving to the practical session. Yeah, first of all, I would like to run the word count program, which we have already seen. So just in the before slide, we have run the, yeah, this is the program we are going to run the program now, word count program. So how this word count program goes on, we are going to see practically, right? And if time permits, I will take the another data set that is called the patent data set, and I'm going to execute that also. Yeah, now to run the Hadoop, there are different ways are there. You can make use of Ubuntu, and you can install the Hadoop. You can run like that. I'm making use of Cloudera, a non-commercial product. Of course, Cloudera is commercial, but as a single user, we can work as a non-commercial things, right? So I'm making use of VMware Player. Let my VMware Player starts. Yeah, it started. And then I'm making use of Cloudera. See, you can, I said already, you can work as like simple Cloudera mechanism, or by using the directly download the Hadoop. Yes. let my Cloudera starts. Right, my Cloudera has started. So I'm going to close this. Yeah, I'm going to close all these old terminals. These are all which I have used previously. Right. So this is my Cloudera. So as soon as you install the Cloudera, you are going to get the screen. Of course, these are all the components you are not going to get. It's my habit of keeping all the things on the desktop, so I kept like that. So this is my terminal window. So in this terminal window only, you're going to perform all the things, right? So this is the default thing we are going to get. So I'm saying PWD, present working directory. By default, whenever you install the Cloudera, you're going to work as a root home Cloudera only. You're going to work as a root home Cloudera, right? So this is your working place. Simply say, just imagine that you are working as a client as from this place, right? From the terminal. So for Cloudera, if you want to work as a web interface, you can click on this browser. See, I told about name node status and job tracker. As I said you that the Hadoop works with the master slave architecture. In master node, we have two domains, that is called as the name node and the job tracker, right? So name node is going to keep the metadata, and job tracker is going to keep the information about the job. The job tracker will get the heartbeat from the task tracker. Yeah, I'm alive, I'm doing your work. And what about the name node? Name node will keep information, all things about data node, and data node is a slave to the name node. Data node is a slave to the name node, and task tracker is a slave to the job tracker. So like that the things goes on, right? So this is my HDFS, right? This part is my HDFS. See, we have got DFS, non-distributed file system. Since I'm working on single mode, that is called as in my MyLappy itself, I'm having a master, and in my MyLappy itself, I'm having a slave. So that is a thing we are going to see, right? And whether all the nodes are working properly or not, we need to check that. That is called as what? Sudo is a super user to give a to check as a super user. I'm checking here JPS, right? So it's going to ask the password. The password I'm giving here. So yes, this is all. This means that all my nodes are working happily. It is just like something like the boss is getting the information about all the employees, that all the employees are working. You see, if all the employees are giving feedback to the boss daily, that means that every employee is working happily, perfectly. If any employee is not giving the feedback directly daily, something goes wrong with him, whether he is not capable or he is ready to search some other job, something like that. So similarly, it's like a software profession. So here also what happens, if any of the node is not working, that means what? We are not going to get the proper service. So all the nodes are working now. My master node is working, my slave nodes are working. So we have got a job tracker, so and task tracker. We have got a name node and data node, and we have a secondary name node also. Of course, these things we have discussed in the previous webinars. Just for an understanding purpose, I am showing all these things. Right, everything is going on fine. Every heart is working properly. Right, I'm going to clear my screen now. Yeah, let us run the first word count program in the Apache Hadoop. It's a simple program. Every textbook runs with the word count program. Yeah, what are the steps we need to follow is, the first and the foremost step we need to follow is, whatever the file you want to perform the analysis, step 1, keep the file which you want to perform analysis into the HDFS, right? And step 2 is what? Run the jar file to perform analysis, right? And then step 3, store the output. in the HDFS. That's it. Job is over. These are the 3 steps, right? Simple steps. But step 2 is the biggest step. We need to write the Java program. We need to create the jar file. All those stuff we need to do it, right? So just for understanding purpose, I will do. Right. Let us create one file, because what is the step 1? I want to perform the analysis. I want to perform the analysis. So which file I want to perform the analysis? Just let us take one example. Let us take one example. I am creating a file to perform the analysis. Just say cat. Cat is a command to create the file according to the Linux Vignan. Right? Right? Now, Vignan Engineering College, Vignan Engineering College is the best college. All of our students perform well in Vignan. Something like this. I have created the file and I have stored it, right? So the job is over. So if you want to see the content of the file, say cat Vignan. Right? So this is the file I want to perform the analysis. What is the analysis you want? My boss wants how many times Vignan has been repeated, how many times engineering has been repeated, how many times college has repeated, how many times these words has been repeated. See, this is a simple file example I am telling. Of course, no bosses wants this kind of analysis. They want very big analysis. So it's not possible for a beginning stage. If time permits, I will cover one more practical advent on patterns, how to count the patterns, right? So this is the first thing. The creation of file is over. The next step is what is we need to keep this file into the HDFS. How to keep the file into the HDFS? There is a command. Hadoop fs minus put. What is the file I want to put? Which file you want to perform the analysis? Just now I have now whether the file has gone to HDFS or not, I want to check it out. So go to the web interface. This is my web interface. Go to name node status. Go to browse file system. So where I have kept root user cloud. This is by default path. So what is your file? My file is Vignan. Yes, I got the Vignan, right? So you can see here the division path. By default, this file is divided into 64 MB. If we are running on cluster, Hadoop cluster, the 64 MB is going to be split into 3 nodes. And how many replicas has done? 3 replicas has done. But now I am running on the sudo mode. In the same lappy, I am running the master and slave. So I have got 1 replica only. So 1 replica only I have got here. And how much that is? 64 MB I have divided, right? So if you click this file, this is the file I want to perform the analysis. What do you want? I want to count how many times Vignan is there, how many times engineering is there, how many times college is there, right? So this is the job I want to perform, right? So first step is over. Step 1 is over, keeping the file into the HDFS. Second step is I need to create the program, right? I need to create the word count program. That is the biggest and difficult step, right? So first of all, what I'm going to do now, let us write the program. Of course, so I have my computer. Go to Cloudera. I have got my files here, right? This is the program I have written, right? So I will try to explain this program, then I will run also. Simple word count program. So this is all normal Java packages, java.io exceptions, util package, string tokenizer. Yes, in the MapReduce, the string tokenizer is going to play a vital role. And these are all my Apache Hadoop files here. These are all my Apache org Apache files. They're all right. So yes, the most important thing is we need to set the path of this jar file. Yes, I'm showing this important thing. Yeah, I'm going to show this Hadoop star.jar. Yes, this is a jar file. This jar file consists of all these packages. This jar file consists of all these packages, right? And if you are installing the Cloudera, Cloudera is something like all under one roof. You are going to get the benefit of MapReduce, Hive, Pig, everything you are going to get. You can see, go to places, my computer, go to file system, go to user, go to lib. Yeah, it takes a little bit of time. So we have Hadoop. Yeah. So how do I have taken the Hadoop jar file? I have not done anything. Just simply I have gone here and I have copied this jar file. Simply this jar file I have copied it. Just simply copy it and paste it in the wherever the working location. I am working at root home Cloudera. So I have copied there. Just simply, right? And apart from that, we have got a pig. All those things are there. So we are having, this is my Hadoop. We have pig also. Yeah, we have got a pig. We have got a Hive also. So that is the benefit of using the Hive, Cloudera. Hive is there. We have a HBase is there. HBase is there. So all is available under one roof only. If you are not making use of Cloudera directly, if you are using Ubuntu, then you have to install Apache separately, Apache Hadoop separately, and again you have to untar the Hive, Pig, all those things you need to do separately. So here we are not going to do that, right? Yeah, I'm closing this. Yeah, so this is the jar file is required because all these packages has been used here, and I'm not going to explain all these things. Just simple things. Yeah, this is my map method, right? So what the map method? Public static class. Map is a static class. It is extending the super class called the MapReduce base class and implementing the interface. What is my interface? Mapper, right? And here I'm making use of map method. It's a built-in method, right? And what the map method is doing? Reading the line, and see, that's what the thing is happening here. Reading the line from program, right? Reading the line, right? And then what we are doing? Breaking into chunks now, right? Every line is read here, every line. The output of this step is this diagram. This is the diagram. Splitting. Next is broken into chunks, tokens, right? So the output for that is this one, right? Next, output collect. We are collecting. What we are collecting? All these things we are collected. Where we have collected? I have collected in the output.collect. Collect is what? Built-in method. I have not written anything here. All are built-in only here, right? That's all. This job is done. Who has done this job? Map. That means what? Up to here, the programming part is over, right? Next, the reducing job is coming here. What is happening in the reducing here? Public static class. Reduce is a method here. So in the reduce method, what I am doing now? Simply, I am doing nothing. What? I have taken an integer variable sum equals 0, and then what I am putting now? While values dot has next. What is has next? If any value is there, what is the value is there? Here, yes. Any value is there? Beer, yes, 1. So here what is going to happen? Incrementation. What is the incrementation here? You are doing incrementation like this. Sum plus equals values dot next. Getting a 1 value, river. 1 plus 2, 2 plus 1. Again like that, 3, like that it goes. So get is a method to get. So like that the counting, the aggregation happens, and the output.collect is going to collect the key and the sum. What is the key and sum here? What is the key? Beer is a Beer is a key. What is the sum? 2. Car is a key. What is the sum? 3. What is the key? Deer. What is the sum? 2. What is the key? River. That's what the output we have collected. Where we have collected? Here we have collected it. Right, that's it. This is the job of map and reduce. And ultimately, the main program we need to write, where we need to set the job configuration, the output key value things we need to set, mappers and reducers we need to set, input and output format we need to set. Yes, the most important is the arguments, file input format and file output format. These are the args of 0 and args of 1. How it works, I will tell you now, right? So just imagine this is a program. So I have to compile this program first of all, right? So before compiling the program, what I have to do is I need to set the path, right? So because without setting the path, if you run, what is going to happen is you're going to get the error. What kind of errors you're going to get? These are the errors, right? Java C, I won't show the errors, so I'm running the program without setting the path. Yeah, these are the errors because we are all working with the Apache org packages which is there in the Hadoop jar file. That jar file path has not set here, so that is the reason we are getting all these errors. So we need to set the path here. So we need to set the path simply, just simple line of path we need to set here. What is the path? Just I'm going to use, yes, over. Path is over. What I'm saying here, I'm exporting. So export class path. So this is a jar file I have shown you just now. The jar file is present in the root home Cloudera. Right. That's it. Now compile the program. Yes, compilation is over. What is the next step? Step 1 is compilation. Step 2 is execution. Once you execute the program, I would like to show these things. What is this? See, I have created wordCount.java file, but how many files we got? Map class, reduce class, and class, wordCount.class. So 3 class files. You have written only one Java program, but how many classes we got? Map is 1, reduce is 1, and wordCount class is 1. So all these 3 classes are separated. So we need to compress them. We need to create a jar file. So this is a jar file which is already created. So how to create the jar file now? We need to create the jar file. Simply, we can give the command to create the jar file. Just I'm giving the command as jar csv cfv. So what is the meaning of this? This is a jar file name, wordCount.jar. WordCount star class means what? I want this class should go, this should go, and this should go. So when you run the program, when you run the command, see, yes, these are the manifest file has been created. The CVF is your manifest file, right? So one class, another class, another class. Now, yes, jar file is created. So what is the step? This step is over. The jar file creation is over. So to create the jar file, what are the things has to be done? First of all, Java program has to be built. Then compile the Java program. Then create the jar file. How do we create the jar file? Step 1, exporting the path. Step 2, compiling. Next, creating the jar file. That's it. Job is over. Finish. Now, just simply last step is running the program. Right? What I'm doing now? Simply I am saying like this. What I'm saying now? Hadoop jar. Yeah. What I'm saying? Hadoop jar. What is the jar file name? WordCount.jar. Where it is available? In the path called as root home Cloudera. What is the program name? WordCount. This is the program name. This is the program name. This is the jar file. Right. What is the file you want to analysis? Just now we have created the Vignan, and Vignan file I have kept in the HDFS. Right. And what about this? This is nothing but my output file where you want to create the output. So I am going to say Vignan output. Right. So this is my args of 0. This is my args of 1. In the program, args of 0 is what? My input file, which you want to do the analysis. My output file is what? Where the output you want to store, right? That is my args of 0, and this is my input file which is already kept into the HDFS. I want to perform the analysis, and this is the output file where I want to store the output, right? So as a client, just simply if you give this command, over, the job is over, analysis is going to perform. Now what we have to do now, simply wherever the data is there, we are going to put all data into the HDFS, and we are going to we're going to create jar files, and we are going to give the jar file to the client. Whenever they want to perform the analysis, they will run the jar file and they're going to get the output. That is the advantage of using the MapReduce. The simple jar files are going to be created. Let us run the program now. Yeah, it's running the MapReduce. Yes, the process is going on. Yeah, job has been created now. Yes. Yeah, map job is over. 100% job is over. That means which phase is over? First phase is over. This phase is over. Up to here, phase is over. Yes. Now reduction is over. So how many splittings has done here? When 36 splits has done, right? Right. And total input records 18. Right. Now the output we have got it. Now to check the output, what I will do now? I'll go to my web interface. Go to name node status, browse file system, root user, Cloudera. What is the output file I have created? Vignan output. This is a directory file automatically created, right? And by default, part-00 file is going to be created, right? So how many times Vignan is there? Yes, it is there for 3 times, right? College is there for how many times? 3 times. Engineering is there for how many times? 2 times from the text file, right? Yes, this is what the analysis we have performed. It's a simple analysis, not more than that, right? So we have got a Vignan for repeated for how many times? For 3 times. And in the word count, and we can see these things, right? If you click on this again, see, you can see the complete report. These are all the reports. Yes, it's showing the graph also, how much MapReduce job has done, simply. Right, so nothing has failed. Okay, so complete attempt has done. What is failed here? Sometimes we give 1000 records and only 90 records is processed, 10 records has not processed. Is it a correct analysis? No, it's not a correct analysis, because 10 records they have omitted, because if you consider 10 records, the analysis may change. Why 10 records has not considered? Because they may not be in a proper format, they may not be a prescribed format, whichever the format we are writing in the program. So at that time, we can check the report by using this failed, killed, all these things. How many records has been left without performing the analysis? That's all, right? So job setup successful, status successful, started time, finish time, all those things it is showing us. Right? The time is 4:38, almost on 4:40. So the time does not permit us to run the patent. Actually, I thought of giving this patent also. These are all the patents and sub-patents we want to count out. That means for one patent, how many sub-patents are there? For 2, how many patents are there? For 3, how many patents are there? Like how the word count, like we have counted how many times Vignan is repeated, how many times engineering has repeated, how many times college has repeated, we have seen. Now, how many times 5th patent is repeated? 5 patent has got how many sub-patents? 4 has got how many sub-patents? 3 has got how many sub-patents? So that counting can be performed, right? So it is not possible for us to do that now as the time is up. right? So these are the things we have discussed in the class. All right. Any questions? If you have, please you can ask me. Hello. Sridhar sir. Hello. Hello. Yes, sir.
Hello.
Yes, sir.
Ma'am, whether we need to install Ubuntu?
Hmm. What, sir? I didn't get the question properly.
Do we need to install Ubuntu?
Yeah, you see, if you want to make use of separate cluster and all, then certainly we need to make use of Hadoop, Ubuntu. Otherwise, like how I'm making use of VMware Player, we can make use of VMware Player, and you can go for any third-party tools like things. Then we can run like that also. But the proper setup, it will be with the Ubuntu only, frankly speaking. So it is mandatory, frankly speaking. Yes, sir. Next question.
Can you please tell me in brief about usage of Hadoop in social media analysis?
Oh, very good question. Whoever asked, I appreciate him. Yeah, actually, frankly speaking, everybody is making use of Facebook. So, Facebook every day we are performing, making use of Facebook. There are nearly per hour it seems 30,000 queries, and every day 3 lakhs new users, 3 lakhs new users, all these things to perform the analysis. The Facebook is making use of Hadoop ecosystems component called as Hive. So to perform the analysis of social media network, the basic reason of arrival of Apache Hadoop is to perform the unstructured data analysis only. As long as structured data is there, okay, well and good. We have got a sufficient amount of tools are there. We can make use of it, well and good. But for unstructured data handling, obviously we require Apache Hadoop. We can make use of MapReduce programming, or by writing Hive or Pig. All these things can be done, right?
What is the difference between MapReduce and ontology?
There is a difference is there. There is a difference in the terminology of steps and time, the number of iterations. How about the ontology is the same wise, the Spark is there. The performance wise it will be increased. Yes.
Is VM Player working as a sandbox?
Yes, yeah, yes. So SAN is a separate. VM player is just a virtual machine. We are making use of it. So we cannot come. Yes, of course, both are working as one type of player only we are making use of. Yes, almost all similar only. But clarity purpose, virtual player is a virtual, a sandbox is a separate. But both are a media of making use of the Apache's framework.
How can we use Hadoop in higher education data analytics?
Oh, great question. Generally, every educational institution will be having every now and then, every year we are going to get new data. But in the olden days, before 10 years back, they used to keep only what you say the student name, address, phone number of parent, all these things. But now we are making keeping of the Aadhaar information, all these things. So Aadhaar has generated a lot of unstructured data. So what we can do is all these unstructured data of students, we can put it into the HDFS, and we are going to keep that data into the HDFS. Maybe they're going to stay for 4 years. So let the data should be there in the HDFS for 4 years. Why? Because Every now and then we are going to perform the analysis. So every day keeping them, taking off, that job should not be done. Let the data should be there for 4 years or 5 years, because even though they leave out of the college, sometimes we perform analysis. This was the thing was done by your seniors, or this much placements was done, or this much achievements was done, to show to the existing students also. We can make use of that. So the educational institutions, they can simply make use of all data, push into the HDFS. They can make use of MapReduce programming, create a jar files type of things. Like for example, to find the number of backlogs, run one jar file. To find the number of placements placed in some company, create one jar file. Something like that, we can do it and we can perform the job.
Can Hadoop be used for data streams?
Yes, it is basically used for that only.
Can we connect web intelligence technique to Hadoop? How? If possible, please give example.
Web intelligence. Yes, it is done, but little bit it is a high-end thing. If possible, of course, in the last session also somebody asked me regarding the machine learning and web intelligence things. So we require to work with some sort of web intelligence, means we can make use of some Twitter's type of data. If we take, then we can perform good analysis for that. Of course, these are all meant for. These are all can be done with Hadoop only. It's, as I said you many times, that taking the professor and giving the KG classes is misusing the quality of the professor. Putting the professor in some engineering class is a good thing. Similarly, using the Hadoop for good thing, like what the question I got just now for analytical performance, or intelligence, or web streaming purpose. These are all the extra and important areas where we require the Hadoop has to be implemented. Right.
Can I use remote database to VMware Ubuntu?
Yes, sir.
And how can I collaborate multiple unstructured database cluster to that?
You need to put it into the HDFS. See, whatever the unstructured, you have terabytes, petabytes, all this you put it into the HDFS. Just how I have done putting into the word count into the HDFS, the Vignan text file into the HDFS. Similarly, you can put it in. Maybe it is a unstructured file, maybe images or audio files, video files. The same method, use the command Hadoop fs -put and put it into the HDFS. That's it. Finish. Job is over. And then write the algorithms, write the programming mechanism. Then they perform the analysis. Generally, long back we have performed an analysis for movie. Generally, as and when movie releases, they perform the analysis. What the movie got hit for this song, the movie got hit for this fight, the movie got hit for the sentiment analysis, all these things. So all the fans keep on tweets. So we take all the tweets and perform the analysis.
How can we implement data lake?
Data lake. Same manner as like the simple thing. How do we form the cluster? See, to implement the data lake and all, we require a big cluster and a good framework of Ubuntu. Then obviously a good frame of a lake can be implemented.
Is it possible to work with video, audio type of data?
Yeah, absolutely. Hadoop is meant for unstructured data. It is saying I am there to perform the analysis of unstructured data, maybe audio files, video files. That's what I said just now. Take one audio file, take one video file, compare it, perform the analysis. Generally, what happens is in a company things, they keep on put the images. Like any production is going on, before delivery of product, they keep on test those images of those products. Which image has got good clarity, which image has got less clarity. All those things can be done with help of analysis only. Something like that. For time does not permit us. The rest I have shown you that part. See, we have something like these are all the images we have. Yeah, we have got images, right? got images. So what I'm doing now here, I want to find out the clarity. This is how much? 94 kb, 24 kb. So clarity. So number of pixels, 11, 12 kb, and 160 days. Yes, 28 kb. So I want to find out the clarity. This is little bit blurred. Yes, this is separate image. So what happening here? My analysis is what? Which image has got good resolution? I want to find out. That is my analysis. So how I am working on images, the same manner we can work on audio files and video files also.
Those are all the questions, ma'am. Thank you very much.
Okay. Thank you, sir. Thank you very much. Right, sir. Thank you, one and all. Right. Thank you so much.
Thanks.